Hello students, today we will going to discuss the classification of matters and the periodicity of the properties in the elements. This is basically the fourth video of this series. In this video we will be going to discuss a very important thing in the classification of elements, that in the periodic table the position of the element is very much dependent on its electronic configuration. Electronic, you can see there is a logical consequence of the electronic configurations of the elements, atoms of the elements, and its location in the periodic table. Any electron is identifiable by 4 quantum numbers that you know. The principal quantum number that signifies the energy of the electron, and other orbitals, other quantum numbers, that is referred to your orbitals in the previous section you have observed, that are also going to influence its position in the periodic table. How that is the main thing in the location, regarding the location of the element. Suppose one element has been shown, and these elements, the electrons has been in which orbitals is to be filled, that will determine its location in the periodic table. Means the orbitals that is to be filled in the required energy level, that will going to create the determine the position of the elements. इसका मतलब ये है जो एलिमेंट है उसको जो वैलेंस शेल का जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन है, वो इलेक्ट्रॉनिक कॉन्फ़िगरेशन जो है दैट विल डिटरमाइन इसका पोजीशन जो periodic table में है क्या है. So position, when we are talking about the position, there are basically two things, that is one is period and one other is your group. The two things that will determine this position. Any element will be assigned a group and also a period. Period is basically the principal quantum number of the valence shell of that atoms of the element. The principal quantum number that starts from n equal to 1 means when n equal to 1, then it will have the period 1. n equal to 2, that is the period 2, and we are talking about the outside shell quantum numbers. So you can see that in the periodic table there is basically 7 periods. 7 periods in the periodic table. So in the first period, that is n equal to 1, the principal quantum number of the outside shell is 1, then it will have the first element, that is your hydrogen. Hydrogen having the atomic number is 1, and it is only the 1s orbital, that is the filling of the lowest energy level. So this is a hydrogen, and another element in the first period, that is helium. This is 2 elements. You can see from the periodic table, that is there are 7 periods, and all the 7 periods, सारे 7 period में number of elements एक नहीं है. First period में that is 2 number of elements, second period में that is you can see 8 numbers of elements, and third period will have the 8 numbers. Fourth periods will have again the different numbers, that is 18 numbers. Fifth period's number of elements is 18. Sixth period's number of elements is 32, and sixth period 32, and seventh period is incomplete. It is having the 29 elements. So every period you can see that is a element, different number of elements. It is not a uniform. The question arises why it is so. So again this question can be answered from its valence shell electronic configuration, and it is the twice the number of orbitals to be fielded in the required energy level. And n equal to 1, when n equal to 1, we know it is there one subcell, that is the S, and in that subcell there is a 1 orbital, so 2 into 1, that is 2, so there is a 2 elements. In the second period, you can see the 2s and 2p, that is the outside cell orbitals. So 2, the S having the 1, P having the 3, that is 4 orbitals, 2 into 4, that is 8. Like this way, you can observe there is a filling of the periodic table with the required number of elements. So you can see that is in the second period, that is lithium, in the first element is lithium, and it is the filling of the 2s orbital, and then the beryllium 2s orbital is being filled by 2 electrons, this orbital is filled. Then the boron is having the filling of the 2p orbitals, then carbon, nitrogen, oxygen, fluorine, and neon. So this way there is 8 elements starting from the lithium to ultimate is neon. Then in the third period you can see the sodium. There is a filling of the 3s orbital, and first electron enters the 3s orbital, then magnesium, and then you can see the aluminum. There is a filling of the 3p orbitals in the aluminum, then silicon, phosphorus, sulfur, chlorine, and your argon. Argon is here the complete cell 3s and 3p is completely filled. In this way, the fourth group, you can see there is a total of 18 elements. Along these 10 are D block 3D condition elements. It starts from the scandium, it is the 3D condition element, and fifth period starts with the rubidium, and this strontium, yttrium, zirconium, niobium, molybdenum, and technetium are all the elements you can see, and it is the 4D condition element. And at the end you can see the xenon, where the 4s and 4p orbital is completely filled. Here in the fifth period you can see there is a fulfillment of the 5s, 4d, and 5p orbitals. In the sixth period, what you see, there is a fulfillment of the 6s orbital along with the 6s 4p, then 5d, and then there will be a 6p orbital. So in this group, that is in this period, 6th period, you will find there is a 32 elements, and after the lanthanum there is a 4f transition elements, and these 4f transition elements has been starting from cerium to lutetium. That is here you can see the 14 elements. So total in this period, the 6th number period, that is your total 32 elements. So you can one thing observe that the period is totally determined by the principal quantum number of the valence cell. Because on n equal to 6, you will find that this is the period is 6. Now in the 7th period you can see again the 29 elements, and after the actinium there is a actinoid series, and these are the totally radioactive element. This is totally the radioactive element. You can see starting with the thorium, then actinium, the rubidium, yttrium, plutonium, american, then urium, berkelium, and last your lawrencium. And after this, there is the element Rutherfordium, Dubnium, Seaborgium, Borium, HS, Hafnium, the mountains, and all those elements you can see. These are all the elements in terms of the period. Now, if we want to analyze, in terms of the groups, you can see Here total 18 groups are there. In the group you can see the valence shell electronic configuration is totally same. You can see here in the first group, this is the first group, this is the first group, and this is your second group. The first and the second group, you can see that electronic valence shell electronic configuration in the lithium is 2s1, sodium it is 3s1, potassium it is 4s1, rubidium it is 5s1, cesium this is 6s1, and this tantalum 7s1. You can see the configuration of the valence shell is totally same, and you can observe in all the groups. In all the groups you have the same electronic configuration of the valence shell, outermost shell, and that is why the properties of the element is same in the group. In the group you can say it is basically a family. You can say in this family the electrical properties of the elements is same, both the physical and chemical properties. So this is the classification. Now you can see 118 elements. The information about it can be compressed in a very simpler, systematic, scientific way. Now you can able to understand, you can able to know the chemistry of the elements very easily. Here you can see all these elements, and this element is further classified into several ways, like this group number 1 and group number 2 and group number 13 to group number 17. They are called the normal element or representative elements. And group number 18, you can see this is the noble gas element, and others, that is from group number 3 to group number 12, it is called the transition elements, and there is a 4 series, 3D, 4D, 5D and 6D. And in the bottom of the table you can see there is an inner transition element, 4F and 5F element. 4F is rare earth element, 5F is actinoid elements, and it is actinoid series, it is called the actinoid series. Now you can see that they are basically the radioactive element, and majority of them is the man-made type. This is prepared, it is not naturally found, it is a man-made type elements. Apart from this, these elements can be further subdivided into the blocks: S block, P block, D block and A block. S block elements are those elements, that is group number 1 and 2. This is called the S block because last electron enter in the S subshell. You can see the electronic configuration, that is the general electronic configuration of this NS1 to NS2. This is the general electronic configuration of this S block element, because the last electron entered into the S subshell. Group number 1 and group number 2 S block element, and this element is very much reactive. It is having the only electrons, only 1 electrons and 2 electrons. The group number 1 element having the 1 electron and group number 2 having the 2 electrons. This can be easily given away to the other elements for the compound formation, and they only form the ionic compound. In this element ionic compound, but apart from the 2 elements, lithium and beryllium mostly are predominantly ionic, and there the soft material, they are the low ionization enthalpy and all the things that we will discuss later on in discussing the periodic chains of the elements in the periods or in the groups. Then there is a P block element. P block element is basically those elements where the last electron entered in the P subshell. Last electron entered in the P subshell, and its electronic configuration, general electronic configuration is NS2 P1 to 6. There are basically 30 elements you can see in a P block. They are basically the this type of element, I would say they're basically the non-metal, but you can see there is a transition between the metal and the non-metal, and there are some elements that you can see that is been shaded here. There is silicon, germanium, arsenic, antimony, bismuth, polonium, and Ag. They are basically the metalloid. Metalloid means there is a transition between the metal and the non-metal, and they have both the properties, metal and the non-metal properties. So these are the 3-block element, and the 3-block element, there is a very special group, that is group number 17, that is the halogen. This is the halogen group. You can see fluorine, bromine, iodine, and in chalcogens group there is oxygen, sulfur, cerium, and yellow. This is all the chalcogen family and the halogen family. Apart from this, there is another blocking, that is the D block element. The D block element, the general electron configuration is n-1, D1 to 10, n is 0 to 2. This is the general electron configuration of the D block element, and there is 40 D block elements you can see. And D block elements are the very versatile of compounds, and they are totally metals and precious metal, that is gold, platinum, you can see here, and it has in the room temperature they are basically solid in appearance, but exception is there Ag. Ag is metal, mercury is liquid in the room temperature, and they have the good properties of carrying the electricity and carrying the heat. They are malleable and ductile, and this is a very special property for all the metals. And their oxidation number variable, they have the variable oxidation number. They can produce the colored ionic compound, and that will be basically taken care in the class 12, and the transition elements. In the transition element, you can learn more detailed study of it. Why they are form the color compound Q produce करते हैं. What is the reason behind that we are going to discuss. And the last, that is a block element, inner transition elements, and its electronic. And this is the lanthanoids and the actinoids. Lanthanoids are called the rare earth elements. You can see it starts from selenium, and it is ruthenium. Last element is ruthenium, and actinoids is thorium, and last one lawrencium. Lawrencium. So this is all the blocking of the elements, and this. Apart from this classification also made on the basis of metal, non-metal, and metalloids. If you see the periodic table, totally there is 78% are metal, and apart from this there is non-metal and the metalloid. The metalloid already seen silicon, germanium, arsenic, bismuth, polonium, and atoms. They are your metalloids. And metal has a special property that we already discussed, and non-metal having the different property than the metal. So that is all for today's video. Next video will have some exercise, which type of questions may arise in this chapter that we are going to discuss. If you like this video, you can share with your friends, and thank you very much for watching. Thank you.